Newton's third law states that for every action, there is an equal and opposite reaction. What this means is that for every force being applied on an object, there's an equal force being applied in the opposite direction. A force is a push or a pull. This can be demonstrated by me sitting in this chair. Currently, my body is exerting a downward force on the chair, and the chair is exerting an equal force upwards on my body. Here's a representation of me sitting in a chair. My mass is roughly 81 kilograms, and my current acceleration is 0 meters per second squared. Net force is equal to mass times acceleration. So when you multiply my 81 kilograms times my acceleration is 0, that comes out to 0. That means my current net force is equal to 0. I'll write that down here. So net force, though, is equal to my applied force plus the normal force. So normal force is working upward against my applied force. My applied force is equal to my mass times the acceleration of gravity. So my mass of 81 kilograms times negative 9.8 meters per second squared is equal to negative 793.8 newtons. So when you write that in the formula, my applied force is negative 793.8 plus force normal. Then you got add 793.8 to the other side, which equals 790, which shows that force normal is equal to a positive 793.8 newtons. This proves that Newton's third law is correct because the force I'm applying on the chair is equal and opposite to the force that the chair is applying on me. Newton's third law can also be demonstrated by moving objects, as this next demonstration shows. What I've got here is a diagram of my demonstration. Here's the wheel of the car, here's the cardboard, and here are the 3 marbles. The wheel of the car is spinning in a counterclockwise rotation, which is causing there to be a backward force applied to the cardboard, which is what caused it to shoot backwards. This diagram shows the wheel after the cardboard was removed. This is now the top of the table, and this is still the wheel. It's still rotating in the counterclockwise direction, but it's getting a forward force applied to it by the table because Newton's third law states for every action, which this action would be the backwards force the wheel is applying to the table, there's an equal and opposite reaction, which is the forward force being applied to the wheel.